Double click on table analysis under statistics, and we're going to use the same data set, HEART2 data set. Let our outcome of interest be cholesterol underscore status 2, and our column variable will be the outcome of our interest, which is chronic heart disease in this example. And under options tab, I am going to uncheck everything except the observed frequency, and will submit the code. Okay, so here is our 2 by 2 table, or the contingency table. If I can make it a little bigger, we see that the individuals with high cholesterol, a total of 1,791, 659 develop chronic heart disease, and the individuals with normal cholesterol, a total of 3,266, 749 develop chronic heart disease. Let's analyze these numbers a little bit more. Risk, by definition, is the probability that an event, for example, chronic heart disease, will occur within a specified group. Mathematically, it is the number of cases in the group divided by the total individuals in that group. Let's calculate the risk or probability by hand. It will make the concept much clearer. I'm going to copy all this table from SAS and we'll paste it in an Excel sheet, and then we will do all the calculations by hand. Okay, so as you see here, the risk, the probability, risk is the probability that an event, for example, chronic heart disease, will occur within a specified group, and mathematically it is the number of cases in the group divided by the total individuals in the group. So now it is easy to calculate. The risk is the number of cases in the group, which is 659, equals 659 divided by total individuals in the group. So divided by 1791. So now we can see clearly that among the high cholesterol individuals, the risk of chronic heart disease is 36.8 approximately, right? Similarly, the risk of chronic heart disease among normal cholesterol individuals is the number of cases in normal individuals divided by the total individuals in that normal cholesterol level group, which is 3266. So now we can see here that the risk of chronic heart disease among high cholesterol individuals is 36.8% approximately, and the risk of chronic heart disease among normal cholesterol individuals is 22.9%. This difference is simply the mathematical difference in risk between the two groups. In our example, risk difference is the risk of chronic heart disease among the high cholesterol individuals minus the risk of chronic heart disease in normal cholesterol individuals, or vice versa. So here we can calculate the risk difference by hand. Risk difference for the high cholesterol individuals would be 36.8% minus 22.9%. So we can see that the risk difference here is 13.8%, meaning that the high cholesterol individuals have 13.8% higher risk of developing chronic heart disease compared to those with normal cholesterol, and vice versa is true too, which will have almost the same, not almost, it is going to be identical value, but with a negative sign. So the risk of chronic heart disease among normal cholesterol individuals would be 22.9% minus 36.8%, which is, as you can see, is the exact opposite of the value right above, 13.8% lower than that of high cholesterol individuals. The relative risk compares the risk of the outcome between two groups. In our example, relative risk could be the probability of chronic heart disease in high cholesterol individuals divided by the probability of chronic heart disease in normal cholesterol individuals, or vice versa. So instead of subtracting one probability from the other, here we are dividing them from each other, giving us the comparison between the two groups. Let's do it mathematically in Excel sheet. So the relative risk of chronic heart disease among high cholesterol individuals is the risk of chronic heart disease in high cholesterol, which is 36%, divided by the risk of chronic heart disease among normal cholesterol individuals, which is 1.60443. So the way we interpret it is the risk of chronic heart disease among high cholesterol individuals is 60% higher than that for the normal cholesterol individuals. I repeat, the risk of chronic heart disease among high cholesterol individuals is 60% higher than normal cholesterol individuals. And we can do the opposite also, which is not going to be the same value or the exact opposite of it because of how the fractions work. So the risk of chronic heart disease among normal weight individuals compared to high is the risk in normal cholesterol individuals divided by the chronic heart disease risk among high cholesterol individuals, and it comes down to be 0.623. And the way we interpret it is as follows. The risk of chronic heart disease among normal cholesterol individuals is 38% lower than high cholesterol individuals. So as you can see, these values are not exact opposite of each other, in contrast to the risk difference, which was a simple subtraction from the risk of each other because of the way the fractions work. And we can interpret again is that the risk of high cholesterol, risk of chronic heart disease among high cholesterol individuals is 60% higher than normal cholesterol individuals, and the risk of chronic heart disease among normal weight individuals is 38% lower than high cholesterol individuals. To calculate odds ratio, first we need to calculate the odds itself, which represent the likelihood of an event occurring relative to its not occurring. Mathematically, in our example, it will be the odds of outcome, for example, in exposed, which will be the probability of outcome divided by the probability of no outcome. Let's do it mathematically, and it will be much clearer. Okay, so to calculate odds ratio, we first have to calculate the odds, and to calculate the odds, we have to calculate the probability of outcome and probability of no outcome separately. The probability of outcome is the same as the risk, but let's calculate it one more time, and let's spell it out as probability of outcome. Okay, so the probability of outcome, let me make it a little nicer. Okay. The probability of outcome is the number of individuals who develop chronic heart disease divided by the total individuals in that group, which is 1791. So this is the same, the risk. So the probability of outcome among high cholesterol individuals is 36.8%. Similarly, we can just drag it down and it will give us the right value. So the probability, let's do it, and then it will be so it is clearer. So the probability of outcome among normal cholesterol individuals is 749 divided by the total individuals in that group, 3266, which comes down to be 22.9%. Now let's calculate the probability of no outcome. Okay, probability of no outcome. I'm gonna just make it a little bigger. Give me 1 second. Okay, the probability of no outcome is equal to the number of individuals who did not develop chronic heart disease divided by the total number of individuals. Okay, so 63%. So the probability of no outcome, probability of not developing chronic heart disease among high cholesterol individuals is 63.2%. And similarly, the probability of no chronic heart disease among normal cholesterol individuals is 25.17 divided by the total individuals in that group, which is 32.66. So now we have the probability of outcome and probability of no outcome separately for high cholesterol individuals and normal cholesterol individuals. In the next step, we will calculate the odds, which is simply the comparison of these two values, which is odds is equal to, let me make it a little smaller, is for the high cholesterol individuals is probability of outcome divided by probability of no outcome, which is 58%, and for the normal cholesterol individuals it is again the probability of outcome divided by the probability of no outcome, which is 77%. So now we have these values which are kind of little exaggeration of the relative risk, but we have now, we can say that the odds of developing developing chronic heart disease among high cholesterol individuals is 58%, and the probability of the odds of developing chronic heart disease among normal cholesterol individuals is 29.7%, and the odds ratio is simply the comparison of these two values. Odds ratio is the odds of chronic heart disease among high cholesterol individuals divided by the odds of chronic heart disease among normal cholesterol individuals, which is 1.95. And the way we interpret it is that the odds of developing chronic heart disease among high cholesterol individuals is 95.6% higher than normal cholesterol individuals, and the opposite is calculated similarly. That is, the odds of chronic heart disease among normal cholesterol individuals divided by the odds of chronic heart disease among high cholesterol individuals, which is 51.11%. And the way we interpret it is the odds of developing chronic heart disease among normal weight individuals is 49% lower than high cholesterol individuals. I know it is quite complicated. For the same table, we now have so many different interpretations, but this is how it is. Unfortunately, I understand that risk difference is the most intuitive values for even the doctors to understand, let alone if we are providing these three different interpretations of the same numbers to the general population, how much it will confuse the normal population. But even the doctors, they do not sometimes understand what is the exact difference between all these values and how these are so different from each other, although the underlying numbers are the same. So let me hide all the unnecessary values from here, and let's get into the most important values here. So I'm going to hide this column, these three columns, and then we will have only three values here, and the way they are interpreted is as follows. For the risk difference, I'm just going to copy paste it here. The way we interpret the first first calculation here is that 13.9% higher absolute risk in high cholesterol group compared to the low or normal cholesterol individuals. Okay, and the way relative risk is interpreted is as follows. I'm going to paste the value here, 60%. Okay, so the relative risk of developing chronic heart disease among high cholesterol individuals is 60% higher than that of normal cholesterol individuals. And when it comes to odds, this is how we are gonna interpret. I'm just gonna paste it here. Sorry. Okay, for some reason it is giving me the values. It's just slightly different, but anyways, the way we interpret odds ratio is that it is, give me 1 second please. Okay, so the odds of chronic heart disease is 95% higher, or almost 2 times higher than high cholesterol individuals. I know it confuses many people, but even when we are reading our scientific papers, sometimes it is confusing, and when it is provided in newspapers with so different values here, that is 13.9%, 60%, or 95%, which one of them is more reliable? Well, the answer is much more complicated. I will just advise you to embrace this complexity, try to understand all this complexity, do all these calculations by hand to have the firm grip on these calculations, because these are the nuts and bolts of categorical data analysis. And if you are in health profession, in any capacity, even as a practitioner and not as a researcher, you have to have the complete understanding of how these highly different values are interpreted, and what is the underlying calculations behind all these values. Hope I have clarified more than I have confused you guys. And then in the end, all I will say is that do all these calculations by hand to have a full understanding of the mechanics behind all these values. See you in the next video.